All right, here we are once again. I'm not sure what's going on. I'm having some issues probably with the internet or the computer or something, but I'm going to try to get through this without wasting any time as much as I can. So let's see what we have today. Simplify square roots with imaginary numbers and solve square root equations. Find the products of pure imaginary numbers. Now, we may or may not get to that second part. For this lesson, I broke it into two parts. So we're actually a little bit behind because, again, this lesson was broken into two parts. If you're looking at your packet, you might notice that this packet has a second part that repeats itself. So just be aware of that. I'm kind of slowing down a little bit in the lessons and hopefully giving people time to catch up if they need it. All right, so what we need to know, the imaginary numbers. So last time we were working with some equations, right? So with those equations, we did things like isolate the x squared term and then take the square root of both sides after doing a whole bunch of stuff like the algebra stuff, just the basic plain old algebra stuff. But we added the step of having to square root both sides so that we get rid of our x squared. And also remember too that when we do that, when we take the square root of both sides, we should also consider the positive and negative solution for that. All right, so what this whole lesson covers today is the idea of imaginary numbers. Now, I don't know why they gave it that name, because it pretty much just means the square root of a negative number. So like if I were to take the square root of -1, so if we were taking the square root of regular 1, it would just be 1. Because remember, a square root is asking what two numbers can I multiply to get this number. But what number can I multiply? So if I have like -1 as my answer, what two numbers could I multiply? You might be saying, well, what about 1 times -1? Or sorry, -1 times -1. And that would not work because a negative times a negative would be a positive. So you cannot get that. You cannot get a negative result from multiplying anything that are the same numbers. Okay, so same numbers. If you really wanted to get one, you'd have to make one positive and one negative, but you can't do that because if you square a number, it has to come out to be positive, right? So it just has to go be positive, because if I have any two negative numbers, it's going to come out to positive, not negative. So that's where this whole idea comes from. That's where all of this is originating from, is that we can't really do anything to get rid of negative numbers in the square root. So we just sort of give it this cursive I looking thing, and that's what we call the imaginary unit. Now, why don't we just say not solvable or no solution or something like that? And that's because this is a very complicated thing, and there is a solution, but it's just not something that we can get to right away. Okay, it's not something that I can easily explain, but basically it kind of goes with parabolas. If you have a parabola that does not touch the x-axis, it's kind of like a no solution, but we also call it complex solution. So if you remember back to that lesson, we were talking about complex solution as well. And sometimes, again, why we don't just say no solution or something like that, because sometimes you will be changing these formulas a little bit, and you will also have to keep working with them sometimes. So if we just stop there and say there's no solution, well, then we just sort of stop and we're not going anywhere, because there is usually more after that. So pure imaginary numbers can be written like this: a plus bi, where a is a real number and b is the imaginary part. So this one has two parts, a real part and an imaginary part. And again, imaginary is not a really good term for this, but just sometimes it is like that. So what we would need to do to simplify a negative root. So this is actually, okay, so now this is the part you should probably pay more attention to. So let's say we have a root number that is negative. What you can do is break it apart just like we did on the last one. Remember, we're breaking them into factors. So with these factors, well, we can factor out -1, because remember, -1 times anything is still going to be -1. Or that number negative. So then we separate the -1. Then we take the root of both of those numbers. So if a is not a perfect square, we have to break it down and take out what we can and leave any leftovers in there, same as we did last time. But if we want to simplify the part of the radical that has the -1, we just replace it with that cursive I, the imaginary unit. All right, so let's go ahead and move on. All right, so let's see, simplifying negative roots. So we still have, I put the directions up there so we could use it. Now, we know how to simplify -9, okay? Simplifying -9 is not gonna be that tough. Okay, my computer's frozen now. I'll let it wake back up. All right, hopefully that does it. So like if I asked you, okay, so -9, well, let's look at regular 9. So with regular 9, it would just be 3. Right? No problem. That would be pretty easy. But again, we have a negative in there. So what we're going to do is we're going to break it down into -1 and 3. Oh, gosh, I'm getting ahead of myself. Because it should be 9. I know it's going to be 3, and I'm already getting there. I'm trying not to skip any steps. Normally, I kind of skip that step because I already kind of know what it's going to be. All right, so we also don't need to really do this. I'm just reminding you that you can take the root of both of these numbers. So I just separate it by giving them each their own root. Now from here, I have -√1, and I'm just gonna replace that with I, and the square root of 9 is 3. And I'm gonna write them in the correct order because we should always have our coefficient, the number, and then the variable, just like that. Okay, now let's go ahead and do 196. So, well, -196, and they're all going to be kind of negative. So let's think of 2 numbers that we can multiply to get 196. And let's think of the largest square number that we have. Now, if you remember from that last lesson, when we were covering perfect square numbers, well, 196 is a perfect square number. Because 196, the square root is going to be 14, because 14 times 14 is 196. Now I'm also going to take the root of a negative number. So remember, this is just going to be I, so I'm going to put I right there. So we have our final answer, which is going to be 14I. Moving along. All right, so with this case here, well, think about normal 5, okay, just a regular 5. Well, 5 is not a square number, so we can't really take the square root of it. And we also cannot break it down because there are no other numbers that can multiply to 5 other than just 1 and 5. So there's no chance of us having 2 of the same factors, so we're just gonna have to leave it in there like that. So when this happens, we have, well, we can take this out, we can take the negative out, and this tells us that it is going to be a root of a negative number. So if you see I, that means that there was supposed to be a negative in here. So just think about using it backwards. So I know sometimes, especially in later lessons, we're going to be working with numbers that have that I. So when you see that I, just remember it's the root of a negative number. And it looks like we're done with this one because, again, there isn't really much we can do. Let's go ahead and do number 4. So here I have -80. So I'm wondering if I can, okay, maybe I'll do this a few more times. And at some point, I'm probably just gonna skip this step of taking out the -1, and we're just gonna start factoring it from there, okay? So we're not gonna be working with much of anything else from the -1. Now, what we got to do is we got to think of 2 numbers that will multiply to give us 80. And we want the largest square number that we can think of. And if you need help, remember, you can always just make yourself a factor tree. And just out of habit, I always do 1 out of 80. 1 times 80 is a way to get 80. 2 times 40 is another way to get 80. 80, let's see, if there's a 3 here, there's nothing I can multiply by 3 to get 80. So let's try 2 and 20. I'm sorry, 4 and 20. 4 times 20 is 80. and 5 times 16. And 16 is a square number, so I'm going to put 16 in there. 16 times 5. Extend that thing out. And now I'm also going to start taking numbers out of the radical. So the first number I can take out is I, right? So we're going to take this -1 out. It becomes I. We're going to take 16 out, which will become 4, because we take the square root of 16, that's 4. And then we look at our leftover. So again, 5 cannot come out of that radical. So since it cannot come out of that radical, we're just going to go ahead and leave it in there. So there's not really anything we can do with it. So it just stays in that radical. So we just have 4i times the square root of 5. And there we go. That's it. Let's go ahead and do this next one. So break it down into some numbers. So -1 times, and then, okay, so now we took the negative out. We don't have to worry about that negative anymore. And that's usually why I do it as the first thing, is take that negative out, because that just complicates things. So let's make a, oh, well, actually 2 times 16 is probably exactly what we need, because 16 is probably the biggest square number that we can use. So 16 and then times √2. So that's the biggest square number that we can make. And there, we can't break down 2 anymore. And even if we could, there would be no square numbers. So let's go ahead and take out our numbers. So we have I. And then we have the square root of 16, which is 4, and then 2. And this is actually going to be our final answer. All right, let's go ahead and do this last one of -192. So -192, well, let's break it down. So negative number, -1, and then 192. Now, sometimes it'll help to get a calculator, and you're going to have to keep trying numbers to see what you can do. If not, well, you can also make a factor tree. And again, I just have the habit of starting with 1, because that's, in most cases, when you're making a factor list, that is one of the numbers that you should start with. Okay. That 2 did not turn out right. So let me go ahead and try again. So 192, and then what you do is you just work backwards with your calculator. So take 192 divided by 2, and that would be 96. All right, I'm not sure what you're seeing, but my screen just froze, and we've been having connectivity issues with the internet lately, and I think that it just lost the thing. And I'm not sure if you can hear me even now. Okay, I'm just gonna have to wait for it to come back on. Hopefully the video on this turns out okay, because I really don't want to have to try and re-upload it again. Oh boy, what is going on with this now? I'm gonna go ahead and pause the, okay, that's taking a while too. All right, I cannot push any buttons. Let's try this again. So 2 times 96. Okay, there it goes. I got control back. And 96 is not a square number, so let's try the next one, which is going to be 3. So this is 192 divided by 3. And we don't need to do this all day, okay? We're looking for the largest square number, which in this case, again, it does help to memorize that list of those square numbers. So 64 is a square number. Now we could keep going with like 4 and 8 and maybe 6 and a couple of other numbers. But right now we've ran into our highest square number. So square root of 64 times 3. Now let's go ahead and start taking numbers out. So we can take the square root of 64, which is 8, replace -1 with I, and we have a leftover that stays in the radical, which is going to be √3. And there we go. So that we have all of those together. And again, this is not really anything different by too much from what you might do in Algebra 1. I think this is covered in Algebra 1. A little bit of roots here and there. All right, and like I said, I'm gonna try to keep things moving along. So let's use this for solving equations. So again, this is what we did last lesson. We were trying to solve these, right? So what number can I square and then add to 81 to get 0? Now remember what this means. Imaginary number means, in a way, we cannot get a real solution, because if I put -9 in there, -9 times -9 is going to be positive 81. 81 plus 81 does not equal 0. Okay, so there really isn't anything we can put in there and get a real solution. So what does that mean? Well, let's start solving it the same way we do. So you start off by using your ordinary rules of algebra, right? So first off, we start with the parentheses and like terms. Then we pick a side for the variables, do the add and subtract, and then we save the, we normally multiply and divide is the last thing we do, but we also have one more option, and that is to take care of any square roots or square numbers, which in this case we have a square number, which means we're going to have to take the square root of both sides. So I just move 81 over to this side so it becomes negative, and then I'm going to take the square root of both sides. So this becomes x, because remember, the square and the square root are the inverse operations. They are the opposites, and they will cancel each other out. So now I no longer have that square root. So it's just plain old x. Also, don't forget, whenever you do this on the root of both sides, you have to consider the positive, negative, and negative possibility, right? Because there are two things that can happen. 81 is already a square number, so I'm just going to go ahead and leave that in here. And like I said, for now, well, maybe I shouldn't leave it out. So 81, let's go ahead and take our square root of 81. That would be 9, right? Because if I ask you for two numbers that will multiply to 81 that are the same number, you would say 9, because 9 times 9 is 81. And then I'm also going to take the root of -1 out. And that leaves us with nothing in the radical, which is good, because if we have nothing in the radical, then we don't need to bother with it. It just stays where it is, right? We just get rid of it. So in this case here, we get x equals positive and negative 9i. Now, again, if I put negative in here, it's not going to work, because negative times negative is going to be positive. So that's going to be 9 times 9 is 81, which I'm going to get something like this, which again, normally that means that there is not really a solution. But again, we use imaginary numbers to get around that, because we don't want there to be no solution. So we say it's an imaginary solution, sometimes a complex solution. And yeah, explaining it can be a little bit tough, exactly how and why these things work. But let's just get enough information so we can complete this lesson. All right, so here I have 1 minus 9, so that'd be -8. And remember, again, if you just got to do what you do normally when you're solving any kind of algebra problem. In this case here, we're going to have to multiply and divide, so that's going to cancel out 2 here. So I get here, let's see, -4. And -4, well, I'm going to have to get rid of this square by taking the square root. And remember, anytime you take the square root, you have to consider the positive and the negative possibility. And maybe I'll do a quick refresher on that one too, because remember, like if I had 4, right? So if I need a number squared, -2 times -2 will give me +4. And also +2 times +2 will also give me 4. So I can make it negative or I can make it positive. Both of them will work. So x squared equals plus and minus. And now again, I'm going to try to do this. Let's see if I can do this in my head. So I want to take the negative out. If I take the negative out, that's going to be I, right? And then if I take the square root of 4, that's going to be 2. Oh, there's no more square here. The whole reason I did the root of both sides is because I don't want that square there. Yeah, we don't want that square there. That's the whole reason why we got that down. Ooh, Mondays, am I right? Also, I have a trip ahead of me, so I'm kind of getting ready for that. I think I sent out an email earlier today just telling everybody that there won't be any afternoon class today. All right, so let's see, 9 and 15. We put those together, we get negative 25. And from here, I am going to have to, wait a minute, negative. This is negative. Oh wait, 9 plus 5. Wait, no. What am I doing? 9 plus 15 is 24. Okay, not 25. I was about to say this, otherwise it would have given us a fraction, and I don't think that they want us to do fractions right now. Maybe at a later exercise, but it's still kind of early for fractions. You know what I mean? So anyway, let's go ahead and keep going. Got to get rid of this division here. So x squared, and then 24 divided by 4. Well, since I already have that number on my calculator, be negative 4. Oh, wait, did I push the right button? No, because I swear my calculator says 4. It's not an error I did, because I know 24 divided by 4 is 6. Maybe I pushed the wrong button, but oh well. Take the root of both sides, because I got to get rid of this square. Remember, when you solve an algebra problem, solving algebra means you got to get that x all the way by itself. That includes things like x squares and stuff like that. So let's see, we have plain old x, plus and minus, and let's look at two numbers that we can use to make 6, 2 and 3. Those are the only numbers that we can multiply to get 6. Neither of these have factors that match, which means we cannot take anything out. There are no square numbers or even a pair of factors in here. So let's put the 6 back together. And that's going to be our answer. So again, 6, we cannot break that number down anymore. Okay, let's go ahead and move on from here. Oh, come on, that button's not working. I don't know what's going on with it. I'm gonna have to just scroll one at a time. All right, negative 13. I'm gonna have to minus 13 on both sides to get that 13 off of here, because I'm trying to get this by itself, trying to get the x by itself as much as I can. So x squared equals negative 12. All right, and again, what number can I square to get negative 12? Well, we can't really do it, so it's going to be an imaginary number. X equals plus and minus. Don't forget that plus and minus. I know it's pretty easy because there are 2 solutions, and we need both of them. So now we have 12. So with 12, let's see. Let's break them into a list. 1 times 12, 2 times 6, and 4 times 3. Which in this case, 4 is our square number. So negative 1 times 4 times 3. And again, you can do this part in your head, and I'm going to keep writing them out in case, you know, it'll help some people that get lost. So here we should be able to get our final answer. So let's see, take the square root of 4, which is 2. Oh, I accidentally put, I should have put a better equal sign here. So equals plus and minus. Now I can go ahead and put 2 and then I, because negative 1. And then the 3, we can't do anything about that. It's not a square number, and I can't break it down anymore to see if I can make any square numbers out of it. So it's just going to have to stay in there. All right, add 5 to both sides. 3x square equals, and then 440. Now, it is going to be a negative number because I obviously have a much bigger negative number, but my calculator cannot use negatives. So I'm going to have to just switch the sign. So it's going to give me 441, but again, that it would still be negative. So be careful with that. And then from here, I'm going to have to divide both sides by 3 because I'm trying to get rid of this 3. And that would be x squared minus, and then 441 divided by 3 is going to be 147. So negative 147. Okay, and then I'm going to have to take the root of both sides. So root here, root there. And that should leave us with only x. Now, I'm going to take the negative out. So here we have 147, but we're not going to write 147 because we want to break it down into two numbers that will work as square numbers. So again, if you need to, let's go and take 147 and break it down into some numbers. And we're using the technique that they had us use in the last lesson, and that is to look for the largest square numbers, which in this case, 147 is not a square number, so we can't take anything out. Let's see, 2, well, I don't think we can divide it by 2, or we can't use 2 to multiply any other number to get 147, so we're going to try 3, which in this case I get 3 times 49. And 49 is indeed a square number, so we're going to use 49 times 3. Now again, if I were to multiply all 3 of these numbers back together, I would end up with negative 147. And that's why it's a factor. Okay, factors mean numbers that you would multiply to get another number. So let's go ahead and get ready to write our final answer. So we have square root of 49, which is 7. And then square root of negative 1 is I, and square root of 3, because it's still under the radical, it can't come out. It's not powerful enough to get out of that radical on its own. So it's just going to have to stay there as a leftover. All right, here we got fractions, and I know fractions are one of those things that people get scared of as soon as they see them, and I know that because on the homeworks, anything with a fraction usually just gets skipped. Now, I'm afraid of running out of space, so I'm going to kind of take a shortcut here to get rid of this fraction. Normally, I would multiply both sides by 3, and then I'd have negative 2x squared, and then I'd divide both sides by 2. But kind of a shortcut is to multiply it times its reciprocal. And make sure you do the reciprocal on both sides. So instead of 2 over 3 negative, we have negative 3 over 2 on both sides. And this allows us to kind of skip a whole step because, like I said, first we'd have to divide both sides, then we'd have to multiply both sides or something like that. In this case here, if we look what's going on, negative times negative is positive. Okay, so the negative is gone. 3 times 2 is 6. Bottom numbers, 2 times 3 is also 6. 6 divided by 6 is 1. 1 times anything is just going to be that same number. So in this case, 1 times x squared, it's just going to be x squared, nothing left. All right, so on this side here, what we have 18 times 3, which I'm gonna not take any chances today. I don't know, my calculations are a little bit off. And then bottom number stays the same. So in this case, I have 54 divided by 2, and that's gonna be 27. Okay, again, my computer's jammed. I don't know what's going on with it. Okay, yeah, see, this is kind of why I'm picking up the pace a little bit so I don't go over time with all this. All right, it's back on. And this should be negative 27. Now, to get rid of that square here, take the square root of both sides. So x equals plus and minus square root of negative 1, and then here I have 9 times 3, because that one's a pretty easy one. There are only 3 numbers you can multiply to get 27, and it's kind of a small number, so I already kind of know what it was going to be. 9 times 3 is how you get 27. Now we start taking stuff out of the radical. I said out of the radical. So we have 9, which we can take at 3. Negative 1 is I, and I have root 3 right there. So root 3 stays in there. So we take the square root of 9. That's where we got this 3 from. So that 9 was powerful enough to get out of the radical. And it looks like we had just enough space. So even though I sometimes don't like taking shortcuts because I feel like people are going to get lost sometimes, I'm not going to go ahead and do that. So well, I did have to take a shortcut, but we made it. We have not just enough space, otherwise we would have ran out. And like I said, because of all these errors going on, I'm going to go ahead and keep things moving along and talk about the powers of I. Now, this is a it's kind of complicated, but kind of easy. Like, it seems really tough at first, but once you really understand what it is, it becomes a lot easier. And actually last semester when I taught this, I didn't get a whole lot done. So maybe I'll try to do another lesson on this one here. I have my own slides that are a little bit better at explaining this. All right, so let's go ahead and look at what we have here. So we have I to the 1 power. And if you remember anything about powers, anything to the 1 power is going to be that same number. We're just going to have that same number over again. So I have root negative 1. And we know by definition on the packet and in the last slides, that would just be I. Now here, I'm going to have another one. So here, what's going on is that we square it. And if you remember, the square and the square root are inverse operations, meaning that they are going to be canceling each other out. So now that we're canceling each other out, so 2 here and square here, that's going to only leave us with, and I'm going to go ahead and bring that back because it would give us negative 1, right? So we have negative 1. Because again, they cancel each other out. And then here I would have, well, okay, so here's where it starts getting a little bit weird because as we get higher and higher with these powers, we're gonna have to kind of do some breaking down. Now, you could also make a chart of this and it would be a little bit easier. Well, actually, this thing we're working on right here is the chart. So I'm gonna break it down into I square and plain old I. And the good thing about this one here is that we don't have to derive so much of it, meaning we don't have to figure it out ourselves because we have it right here. We know that I square is negative 1 times regular I, which in this case is going to just, well, it's going to stay I. So in this case here, negative 1 times I is just going to be negative I. And I'm going to make that a little bit better. There you go, negative I. So again, negative 1 times any number is just going to make that number negative. Now let's go ahead and work with another one here. So I have I square times I square. Now we know that I square is negative 1. So this means negative 1 times negative 1. Negative 1 times negative 1 is positive 1. So this is going to be positive 1. All right, so again, it seems pretty tough, but if you have this chart, everything is going to be kind of easy because you can just look at the chart and see what number you would get that would be closest to this number. So let's go ahead and move over to I to the 5th. Now I need 2 factors of I that are easy to work with. And again, I'm going to go with I to the 4th because I already have that. I know what I to the 4th is. And then I to the 1, which I to the 1 is just I. So let's go ahead and work it out. So we know I to the 4th is 1, right? And that takes care of this part here. We know that it's going to be 1, and that means 1 times I. We know from multiplicative identity property, 1 times anything is just going to be that same number. So we just end up with I. All right, let's go ahead and do I to the 6th. Now the good thing about this again is I can use I to the 4th again. So I to the fourth, and in this case, it's going to be I. Gosh darn it, my computer froze again. I thought I plugged in. Let me check my wires. Okay. Okay, I'm not getting any, I don't have any, I'm not using Wi-Fi, so I should not be getting any errors. I don't know, the internet, even at my house, was kind of out too, so it's probably just something going on. Or do I have control of this thing again? But we're supposed to get I squared. Okay, good, it's working. I squared here. So again, I to the 2, I to the 4. When you multiply powers, the powers will add, and they will add to 6. So here I have I to the 4, which is going to be 1 times I squared. And I already know what I squared is going to be. It's just going to be -1. So I squared, I'm going to take this off and replace it with -1. So 1 times -1 is -1. See, not too bad. Let's go ahead and do number 7. So I to the 7 power. And I'm trying to use 4 powers. You'll notice that on this column, I'm using all 4 powers. 4 powers are pretty good because it always just comes out to be 1, which means it's just going to cancel out. And here I'm going to have one number of I to the 3rd. And again, I know that I to the 4th is just going to be 1 again. 1 times, and what is I to the 3rd going to be? It's just going to be -I. And 1 times anything is just going to be that same number. So that's going to give us -I. Now, look at the pattern. Do you notice anything? I, -1, -1, -I, -I. What do you think this number is going to be? 1. Because I to the 4th times I to the 4th means just 1 times 1. Now, what I meant by it's kind of complicated, but it's also kind of easy, is that this number repeats itself every 4 times. Every 4 numbers, it will repeat itself. So we're going to use this pattern to simplify it. Now, to make this a little bit easier, what I'm going to do is I'm going to break this into powers of 4. Now, there's also a division thing, which is the old way I used to teach it. I used to teach it like it was a division problem. But I'm going to try something new and see if I get better results. Like I said, last semester I didn't get good results, so I tried to look up some other methods. So let's do this. Now, we want powers in multiples of 4. So this means 4, 8, 12, 16, 20, 24, and so on. So what's the highest number that I can go to 15 by counting by 4s without going over? Well, that'd be 12. So 12 and 13 will combine to make the power of 15. Okay, now this is going to cancel out. Anything with a 4 power is just going to cancel out. Gone. All right, because we already know, like if I continue this pattern, right, I to the 8, it would just be 1. So 1 times anything isn't going to change anything, so that's just good to leave out. Now what we have to do is look at I to the 3rd. I to the 3rd is -I. So all this just becomes -I, and that's it. Yep, that's it. Nothing else. Let's try the same thing with an even larger number, like in this case, 62. So I'm going to have at least 2 I numbers. Let's try to keep it simple, try to keep it at 2. Now, I know that 64 is divisible by 4, okay? So I'm going to -4 from that, and I get 60. So I to the power of 60 and I to the power of 2. And again, I have to make a number that is divisible by 4, which 60 is divisible by 4. It's 4 times 15. But again, that's not important. Forget it. It's gone. Once we have a 4 power, we don't need to worry about it anymore. So again, let's just look at what's left over. In this case, it's the I square, which means that we are just going to have negative I, and that, sorry, negative 1. Negative 1. Because again, we just look at what I square is. This part is the only part that we're focused on. Other part, we don't care. It's out of the picture. It just boils down to 1. 1 times I square. And then we simplify I square and we're done. All right, let's go ahead and move on to, I think, what would be the last slide, I think. I don't know if there's any more. I can't skip slides. 1, 2, 3, and then that's 20, and then that's the end of it. So this will be the last part of this exercise. And like again, so this is where this week's packet begins. I think it starts on, actually, I think it started on the last slide. Yeah, so it's kind of broken down. I took this lesson and broke it into 2 parts so we could slow it down a little bit and catch back up to where we're supposed to be. Anyway, let's go ahead and do this here. So this one here is pretty easy. Just like if I were to multiply any numbers, like if I were to say, 4a times 7a, if I asked most people this, they'd have a pretty easy way of explaining it. They'd say something like you multiply the numbers and then you multiply the letters. So in this case, a times a would be a squared. And you end up with 28a squared. All right, so 28i, because we're working with I squared. Now from here, if we look at what I square means, go back to the last slide. And again, it's easy if you have this chart. So we have I square and we know that it just simplifies to negative 1. So this means if I were to take out the I square, it would just boil down to, okay, my computer froze again. I don't know, maybe tomorrow or so with my 3rd hour, I'm gonna make a better video. I think it's just the internet. The internet's just not doing what I want it to do. And when this happens, I can't push any buttons, nothing whatsoever. Yeah, this is starting to be a real inconvenience. Okay, there we go, the thing's back. So from here, 28, and we already know that I square, we're gonna replace it with negative 1. We're not taking the root of anything. I don't see any square roots, so we don't need to take the root of anything. And then 28 times negative 1 is just gonna be negative 28. All right, and that's it. We're done with this. So now I have, for this one, 3 terms. And like I said, I'm gonna try to get this going a little bit faster because I'm losing a lot of time just waiting for this thing to come back on. So 4 times 2 times 9. So that's gonna be 8 times 9, which is gonna be 72. Oh, in this case, I have a negative and another negative. So actually, I guess it would work out because it would just be positive. And then I have I to the 3rd. Now again, look at your packet and look at what I to the 3rd comes out to be, which in this case, I to the 3rd comes out to be negative I. So 72 times negative I to the 3rd. Oh, wait, no, I took the 3rd out. The whole reason I did that was so that way we wouldn't have to put the power. We use the power, again, that I guess I'm gonna have to go back there anyway. I to the 3rd just becomes negative I. So switch it out. And remember, negative times any number is just going to make that number negative. So in this case, we're going to end up with negative 72i. And the network went out again. Yeah, but it would be negative 72i. All right, sorry. All right, it looks like it's coming back. There we go, negative 72i. All right, and like I said, I'm gonna try to keep things moving along. I don't want to spend too much time here because, again, we're losing a lot of time. All right, so 2i to the third. So if you have a power, well, okay, if you're not sure, one thing you can do is write it out. So I used to have a teacher who would always say, when in doubt, write it out. So if we have 2i to the third, it would actually look something like this. I would have 3 sets of those things. And in fact, since I wrote it out, I don't need this thing anymore because now we can see all 3 of them. So 2 times 2 times 2 would be 8i, and then there's 3 of them, so that'd be I to the third. Then I'd have 5i here. There we go. Now I only have 2 numbers, 2 terms, 8 times 5, which would be 40, I to the fourth. And if we go back to our chart, I to the fourth is just 1. So this is 40 times 1 because I took that out and it just goes back to being 40. Not too bad. Excuse me. All right, let's see. I root 3. And I'm not going to play too many shortcuts again. There is a way you can do this a little bit faster. And it's kind of like distributive property, but again, I wouldn't want anyone to get confused and have to go back. So I'm gonna just do this the long way around, even though it takes a little bit more time. All right, so I used the square and I made 2 groups of each of these groups. So I times I would be I squared. Root 3 times root 3 is root 9. Over here, I have negative times negative, which is gonna be, well, positive, 64 I squared. And then let's go ahead and I'm going to take the square root of this number here. So this would be 3. Make sure I didn't lose any of these. Oh, this should be I squared and this should be I squared too. I times I would be I squared. And then let's go ahead and multiply this together. 3 times 64 is 192. I to the fourth. Now again, I to the fourth means that you just get that number. So that would mean this is going to be 192. So again, I to the fourth, every 4 powers, it goes back to just being 1. And then after that, it goes back again to being the other number. And you just got to know which one of the 4 it lands on pretty much. All right, last slide, and then we'll be done. And again, I'm trying to go through this. I'm not trying to, and I would be not trying to make this, tough for anybody. All right, how would be the best way to do this one? I should probably take out the I first. So this would be root 18 times, and I'm going to take out the negative on this one too, because I'm going to take out the negative first. And this would be I squared times root 180. All right, now I have to break down 180 into 2 numbers that I can think of. And I think we've done this one before, and that was 36 times 5. So I'm going to take the square root of 36, which in this case would be 6, and I'm going to put it with the I. So again, regular number, then I, or any variable for that matter. 6i times 5. Oh, and this x squared, actually, you know what? I could simplify the x squared again. So x squared, actually, you know what? Let me just go back up this whole step because I think there is some more stuff I can do. Because remember, x squared, if I go back to, I can't skip slides anymore. I don't know why it took that away from me. But it would be negative 1 times root 6 times root 5. So now all I have to do is just make this into a negative, and we are done. And I think that's it. Yeah, there's nothing else much we can do. All right, and let's do the same thing with this one. I times root 24. And I'm going to take the I out of this one. And that taking the I out just makes it so that way the negative is out now. We don't have to deal with that negative in the root anymore. And then here, let's go ahead and multiply all of the I together. So we have I to the third, and then 24 times 6. That's going to be 144. So it's all under square roots. So since they're all under square roots, they're going to multiply together. And also from last lesson, and I don't see any from this one, but if you have any numbers on the outside, you have to multiply anything you take out to those ones as well. So in this case, again, root 24 times root 3 times root 2, or multiply those together, you get root 144. I to the third, what does that become? I to the third becomes negative I times, and here we have the square root of 144, which would be pretty easy. It'd be 12 times I, and then the negative pops on over here. So we have negative 12I. And there we go, we're done with that one. And we're done with the whole lesson as well. So again, this is actually going to be 2 packets. So when you get this week's packet, I forget what week we're on, I think we're on week 15. This is also going to be on there as well. So it's going to count as your Monday's attendance, Monday's assignment. Don't forget too that parent-teacher conferences are showing up. So in the parent-teacher conferences, it's going to be, time. I sent an email out to everybody. I'm going to go with students first, and then probably tomorrow I'm going to see if I can get a list of parents to call. I think I still have my remind.com thing, but I don't know. It's going to be a bit of a headache to do this, but I'm probably just going to call everybody if nothing happens. I think that's what I did last semester, is I just ended up just having to call everybody one by one. So anyway, that's it for us today. I will, tomorrow is half a day in early dismissal, and Wednesday is also early dismissal. And again, the parent-teacher conference is on Wednesday, and that's why we have early dismissal. So the next class we will have will be Thursday. So I will see you Thursday. Bye-bye. And I'm going to upload this video. Oh, bye.